50 to 90.
Okay.
Right? And so if they want to know what percentage of the students will have completely examined under 50 minutes, it's that left side of the tail that it's under that 50. Does that make sense?
Okay. Okay. Okay, I see that.
Yeah.
Okay. Oh man. I see that.
A long
Okay.
time to get that
It's
concept.
been a long time. I still don't understand why it's only 2.5 though and not, I understand that it's half of 5, but why is it 5 though? That's what I don't understand. Why is the whole thing 5? That's what I don't understand.
It's like if you have your probability can only be like a total of 1.
Okay.
So if 95% of the data is taken up by that two standard deviations,
Okay.
you only have 5% left. Does that make more sense?
Oh, okay. Okay, yeah. Okay. Because we're using the 95% rule. We're in the 95% range.
Yeah.
Oh, I see. I see. Okay.
Are we good to go to question 6?
Mm-hmm.
Yeah, let's do it.
The LSAT are approximately normal with a mean of 150.7 and a standard deviation of 10. Queen's School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admission. Find the 35th percentile LSAT scores. Give your answer accurate to 1 decimal place. Use the applet.
Okay. I don't remember how to do this. Are we finding a z-score?
Yeah, so I think you first have to put that probability into the applet. So put like 0.35 and then just highlight the leftmost side. And then
It's only
find the z-score.
Is that it?
no,
Well,
and
then you have to z-score and solve for the actual score.
So we're taking the z-score of 0.935 or negative.
Mine is negative 3.85 or 0.385. But that could be wrong. 1 second, let me double check.
Oh, no, you're right. I don't know. Oh, I had it highlighted before I pressed enter. Okay.
Wait, I'm so confused. What are you guys doing? I'm so lost now.
So you type in the area 0.35 and you just highlight
with only the left highlighted.
Oh, okay. So the z-score is negative 0.38, right?
Yeah.
Okay.
And then remind me, the score for the formula for the z-score is z equals the score, like the score that we're looking for minus the average.
Minus the average over, it would be the standard deviation?
Yes.
Yeah. And are we doing...
And you don't have to...
You don't have to do the square root, right?
No.
Of the...
I don't think so, because we don't have a sample size.
Okay, so that we don't need to do that then. Okay. So we're doing 157 minus... So, oh, wait. We're doing negative 38? No, wait.
Negative
0.385
times the standard deviation, which is 10.2.
So wait. Okay, so find the 35th percentile. So we're looking for... What are we looking for? We're looking for the...
You're looking for the score. So basically, you're looking for that number that you would subtract the mean from. that's like on top. So
Okay, I'm like trying to algebraically okay, think of this. I don't have any paper with me. Okay, so you would multiply the standard deviation, right?
yeah,
Okay.
and then you would add 150.7.
Right, right. Okay. Standard deviation. So 10.2 times negative 0.8.
Negative 0.385 is what I got for the z-score.
I got negative 3.927 plus 150.7. So I got 146.773.
I got the same thing.
Okay.
Yep.
Oh, I see. Okay.
46.8, so you said by to 1 decimal.
Okay, so 146.8.
Yeah, that's what I got.
All right, question 7. A team of dermatological researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were part of the research team and take a sample of men from this age group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose that the sample size for this study was 2. What would be the shape of the distribution of sample means? Should it still be skewed right?
That's what I would guess.
Because the sample size is too small?
Yeah, that's what I would guess.
Skewed right means that the hill part is on the right side.
It's like, I think the hillside might be on the left.
Or the hillside's on the left.
Right.
Okay.
Someone told
I've
me-
always had an issue with that.
Someone told me the way to remember it is if you like look at your feet, then
Mhm.
like your feet follow the same pattern. So if you look at your right foot, your longest toe is on the left.
That is crazy.
That's good.
Oh, that's funny. Okay. Cool. Okay. So I'll just put skewed right.
So skewed right.
I guess so.
Mhm.
Right, so I guess question 8. Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. A factory of manufacturers, the tank of trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of tanks is normally distributed with a mean of 8,544 gallons and a standard deviation of 12 gallons. Suppose that a simple random sample of 20 tanks is selected and the simple mean capacity is found to be 8,550 gallons. What is the z-score corresponding to this simple mean? Round your answer to 3 decimal places.
So this one's the same, but instead of just the standard deviation on the bottom, it's the standard deviation divided by the square root of the sample size. Is that right?
I believe so.
Yeah.
So it would be 8,544 minus 8,550?
I
Yes.
think it might be swapped.
Wait,
See,
what?
that's what I'm trying to figure out.
Oh, wait.
I think it's 8,550 minus the 8,544.
Oh, yeah, I see. Because it would be the whatever piece of data minus the mean.
Oh, I see. I see. Okay. All right. 8,450. The Z-score? Did you guys get 2.236?
Yeah, I did.
2.236?
Yeah.
Yes. Okay, what is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8,540 gallons? So,
So we do the same thing, but just put the Z-score in and solve for the probability. All right.
So sample mean capacity of 50. So are we looking for what are we looking for?
I think you're solving for the Z-score again, but then you'll just put the Z-score in the normal probability output, and then it will give you the
and then the right.
what will be greater. So you'll select everything to the right of whatever your Z-score is, and then that'll give you the probability.
Okay, wait, so same formula, but we're plugging 50 instead of 20?
Yeah, and then you're using 8,540 instead of 8,550.
8,000 instead of 8,550?
Yeah, you're using 40 instead of 50.
Okay, let's see. 8,000. Okay, so we type it in. What did you give us the Z-score?
I got negative 2.357.
Okay, that's what I got too.
Me too.
And then we just click the right side.
Yeah, you just select everything to the right.
So 0.009.
Are you selecting everything to the left or to the right? So I got 0.9908.
Wait, why did you do that 0.99? Why did you click all that?
Wait, did you make yours negative? Is your Z-score negative?
Yeah, mine is negative.
And you clicked everything to the right?
Yeah, everything to the right.
So the middle and the right part.
Why the middle part?
Because you're doing it everything to the right from that negative Z-score, not from the positive one.
Ooh.
You know what the red line is?
Yeah, I know, yeah.
So yeah, so since the Z-score is negative 2.357, that's where that hits on the line, and they want to know what's the probability of everything being greater than that score. So that's why it's everything that's to the right of that line.
Even if it's a negative z-score, really?
Yeah, if you got the positive z-score, then you would just do that little bit on the right. But since it's the negative, you want everything greater than that. So that would include the middle.
Okay. Okay. So negative, so 0.9908. Okay.
So you're putting in 0.991.
Yeah.
Is Taylor still here?
Yeah, I'm here.
Okay.
Sorry, I just hadn't heard from you in a while.
You're good. I'm just listening.
Okay. Question 10. Which one of the following best describes the notion of the significance level of a hypothesis test?
The probability of a type 1 error.
Yeah.
Oh, great. Next one's our favorite question. Question 11. The heights of young adult females in the United States are said to have a population standard deviation of 2.6 inches. A sample was taken of 85 young adult females at BYUI, and the mean was computed to be 65.4 inches. Which of the following explanations describes the correct way to interpret the 95% confidence interval for this problem? Mark all that apply.
Oh, goodness.
What do I think of this question?
I think it's C. I remember that.
Julie, I feel like you always rock this question.
Yeah, seriously though.
Every time I'm just like, I'm just gonna pick one random.
C and then E? The last one?
I think that the last one is true.
We are 95% confident that the true mean height of adult females in the United States are somewhere in our confidence interval.
The ending kind of throws me off.
I think it's the next one up. Oh, no. Yeah, I think it's the last one. Yeah, I think you're right.
The first one could potentially also be one
Mm-hmm.
because it's just from our sample.
I've tried those and they're usually wrong, though.
Oh, really?
Yeah.
I trust your judgment better than I trust mine. So.
Well, it's gonna be like question 8 last time. There's 5 different options.
Yeah,
I don't know why they're tricking us.
We're just gonna say 3 and 5, and we're gonna move on.
Okay. If I'm wrong, I'm so sorry.
All right. Well, marine biologists have been studying the effects wow, I totally just forgot how to say that word.
Acidification?
Certification.
It's been a long day. Millions of weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follows a normal distribution. The population standard deviation of weights of male beluga whales is 125, and the researchers feel comfortable using the standard deviation for their confidence interval. Are the requirements for the use of a confidence interval met? Explain.
Does it say that they're normal?
Yeah.
It follows the normal distribution.
Where does it say that? Oh, then, yeah, then it should be yes.
The second one?
Yeah, I think so.
Question 13. An investor with a stock portfolio worth several $100,000 sued his broker and brokerage firm because he felt that a lack of diversification in his portfolio led to poor performance for many years in a row. In effect, to avoid close public scrutiny, the firm agreed to settle the conflict by an arbitration panel. The arbitration panel compared a sample of 39 months of the investor's returns with an average of the Standard & Poor's 500 stock index for the same period in order to determine whether there was a substantial decrease. The data are reported in the rates of return. The S&P has a known population mean return of 0.95. Suppose that you are a member of this arbitration panel. Conduct a hypothesis test to determine if the investor's portfolio performed significantly worse than the performance of the S&P 500. Use a level of significance of 0.05. What is the p-value for this test? If your answer accurate between this one.
So is this an independent?
It's just one sample, though.
Oh, is it?
Mm-hmm.
I would guess would it just be like the regular one?
What would it be?
Test.
So would it be?
This is quantitative data, correct? So it would be like a one sample t-test?
I think so. This is just one sample. Yeah. Eesh. Oh. This is not working for me.
So I give it like a really high T value.
You get a p-value. That is 0.128.
Copy.
What is the null hypothesis?
P-value is 1?
Well, what mine says 2, but I didn't change the null hypothesis yet, so I don't know what to change it to.
Wait, what type of test is this? Oh, slightly worse, so it would be less than.
Less than, yeah. Mine just happened to already be on less than.
What is the null hypothesis? Would it just be 0? Yes.
Yeah.
The p-value I got was 0.128.
Yeah, I got the same.
Okay.
Okay. Question 14. A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why?
Would it be B, dependent? You need to select a couple for a sample.
Yeah, I think so.
Usually, that's usually the case. B.
This is like the longest quiz.
Did he finish it? How much was that?
3.
My thing? Okay. Okay, we decided on B, right?
I think so.
Okay.
your plates in the oven.
Okay.
Okay, information. Use the following information to consider next step. Prices of supply and demand act directly on the prices of airline tickets. As seats available on the plane begin to fill, airlines raise the price. Seats on a flight do not sell well. An airline may discount the tickets or even cancel the flight. Ali Heinrich at BYU Idaho State wanted to determine if there's a difference in the price of tickets listed 90 days before a flight compared to within 14 days before the same flight. For her study, she compared the prices at airline flights from London's Heathrow Airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares for 90 non-stop midweek flights 90 days in advance, and then found the lowest published price for the same destination again 14 days in advance. Prices in US dollars are given in the file direct flight costs. Notice that for some destinations the flights were not available. Question 15. What is the p-value for this test? Round your answer to the 3 decimal places. So this one would be a dependent one, right?
Yes.
A dependent one, so it's a paired sample one?
I believe so.
Mm-hmm.
Why?
Because the flight you choose for the first one determines which flight you choose for the second one.
So let me
Which
see.
one do we put first? Would it be 90 days first?
I don't know if it
Does that matter?
will matter. I will try it out and see if it changes anything.
Let me see. Copy. Let me see what she said. She said she recorded the lowest published fares 90 days in advance. It seemed that she looked at the 90 days beforehand.
Do any of you guys have the one pulled up with the 14 days as your first one?
You should.
You can compare if they're the same.
I'll do that.
It shows that it doesn't work if you do them in the opposite order. Like, it doesn't for the differences.
Well, sometimes it doesn't matter,
I
you
just
know.
on mine I switched it to the 90 days first, and it shows in differences #ref. Like it doesn't work.
Okay.
So I'd probably go with just the regular one. Well, how it is on the spreadsheet.
Okay. Let me see. So I put, let me see. I put the 14 days first and then the 90 days second.
Okay. I may have just messed up something. 1 second. Let me try this again. Okay. You have 14 days first, is that right?
Mm-hmm. So everything seems to work.
Yeah, let me put it in the opposite and see if it changes anything.
Let me take. Is she looking for the difference?
She's looking for the p-value. Okay. For your p-value, did you get 0.09568?
Yes.
Yeah.
So I don't think it matters which order you put it in there.
Yeah, that's usually the case because the confidence interval like either changes just negative or positive.
Yeah, that's right.
So so it would be 0.096.
I think so.
Mm-hmm.
Yeah.
So then for question 16, it would be no, because the p-value is greater than the level of significance.
No. Yeah, no.
Yeah.
Okay.
Okay, 17. A real estate company wants to evaluate 2 of their home appraisers for consistency in preparation for their annual state certification. It is important that different appraisers be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive the estimates of each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied?
What does the QQ plot does again?
I think it would be C. Are you asking about the QQ plots?
Yeah, I was just asking what that means. If it's a straight line.
Oh, do you remember how it's like the graph where you put all the data in and it like forms a diagonal straight line? That means it's normal.
Okay. So it just means it's normal if it's straight.
Yeah.
Okay. That was good to know.
Do you think it's C or no?
That sounds good to me.
Yeah.
Okay.
So 18, now suppose the company of the previous question wants to use a hypothesis test to determine whether the estimates given by the 2 appraisers are different. Which of the following would be the most appropriate pair of hypotheses for the test?
Different.
Yes.
Would it be A?
I think so, yeah.
Think so. Okay, so 19. So suppose you create a 95% confidence interval for a mean and get negative 2.346 and 8.775. You've been told to report this by saying we are 95% confident that the true mean is between negative 2.346 and 8.775. Exactly what does this mean?
Julia, this is all you.
I think yeah, I think it's B.
Okay.
I can't explain why, honestly, but that's usually the answer.
I trust you.
I'll just learn to look for that phrasing.
It just is.
It just is.
Okay. Question 20. If p equals 4 divided by 5, what is the smallest value of n that satisfies the requirements for a normally distributed?
P hat.
Like the sample size one?
Is this the one where it has to be like greater than or equal to 10 or something?
Yes.
Oh. Let me see.
Yeah. So it's like,
Which one is that one? I have to look at that formula because I want to see.
Okay.
so
4 divided by 5 equals 0.8. So that just has to be something where 0.2 times 10 equals, or 0.2. I don't remember.
I'm looking for it. It's like n times 0.2 is greater than or equal to 10. And then it's like n times 1 minus p or p hat is greater than or equal to. Oh, here it is. Okay. So are we looking for p hat or are we looking for p?
So I think we're looking for P. We're looking for N. So if P equals 4 out of 5, the lowest one is going to be 1 minus 0.8, which is 4 out of 5, which is 0.2. We just got to find what? Well, we could just divide 10 by 0.2. So it would have to be 50.
Would it be 50?
Because 50 times 0.2 equals 10.
We'd have to do that for each one, don't we?
Well, I mean, like if you look at it, the P is going to be 0.8 if it's not minus 1. So you just have to use the one that's going to be smallest and multiply that by the sample size, because the larger one's going to be greater than 10 if the smaller one is.
Oh, so we're just using the NP. Oh, okay.
So I just did the N times 1 minus P.
Oh, you did the N times 1 minus P? Oh, okay. So you got 0.2 out of that. Okay.
yeah.
Oh, because I've tried this and I've always gotten the answer wrong. Maybe I've just did the wrong formula. I did the opposite formula. That's why.
Yeah, sometimes it's hard to tell which one to use.
Okay. All right then. So it was 50?
Mm-hmm.
Okay.
Alright, 21. Your little brother has a career batting average of 0.233. You want to determine the probability that he will have a batting average of over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion p hat will be approximately normal?
What are we multiplying though?
I think we would have to do 0.233
Times 40?
because if you did 1 minus 0.223, it would be like 0.8. So it would be larger.
We're not doing the 0.250?
But I mean, if we do 0.233 and 0.2, then we know that 0.250 works already.
Right.
But 0.250 equals 10, and 0.233 is less than 10. So I don't actually know.
So would it be D?
So wait, 40 times 0.233 is less than 10?
Yeah, it's 9.32.
Oh. Do you want to go with that?
I think so, because p hat is just the mean over the sample size. So we would be taking the mean, which is the 0.233.
Oh, okay. So you're looking at his average.
Basing it on that one more than what we want to determine.
I think it is D. Okay.
Question 22. A geneticist takes a simple random sample of 140 gamete sex cells from the testes of a dog to determine the proportion which contain chromosomes for development into a male. Assume the unknown true proportion of the dog's gametes that contain male chromosomes is 46%. The geneticist conducts a survey and calculates P that equals 0.512, which of the following is the most correct interpretation of the statistics? I would say the last one.
I think I remember seeing this question before. I just don't remember what the answer is.
Because we don't know if it's going to fertilize all of them, but we do know that they have the chromosomes, right? And it's just for the sample.
Mm-hmm. Yeah, that sounds right.
51.2 of the gametes in the sample have the male chromosome. So in the sample?
Yeah, I think so.
Okay, that makes sense. Okay, so question 23. Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 decimal places in decimal form. So we're just doing the same thing like we did before, right?
I think so.
Right, but I don't understand. What are we taking?
Or we just use the percent as like the mean that we're subtracting. Like take 320 out of 750 and then subtract that from 45%.
Oh, so 320 divided by 750, that would be the number?
But I don't know. And they don't give us a standard deviation.
Right.
Oh, do you think it's a proportion one?
If it is, what are we doing with that?
Let me get it up.
Be like
And find
the x over n one.
So you would put in, so in one proportion, you'd put in 320, and then for the end part, you'd put 750.
So for your null, would you put 0.45, you think? Or no?
I'm not sure about yet. Trying to figure that out. Let me see.
Oh, so like would we just use like the z-score that's like p hat minus p over the square root of p minus p times 1 minus p over n?
I think. Let's see.
Oh, to find the, wait, are you not finding the standard deviation?
I don't think you need the standard deviation if you're using proportion, because the bottom would just be, instead of having the standard deviation over n, it's like p times 1 minus p, so it would be 40.45 times 0.55 divided by 750, and then the square root of that.
Oh.
What is p hat? Is p hat going to be the 320?
P hat would be the 320 divided by 750.
Oh, yeah.
320 divided by 750?
Yeah.
Yeah, that makes sense. That's what I thought. It was like a proportion.
So then what's p?
P is just the original one, so it would be 0.45.
So the what?
It would be 0.45. It's that original 45%.
What is a null then?
No.
Do you think it's 0.45 or?
Wait, what do we need to know the null for?
If, I think you can use the Excel file.
Yeah, I would probably say 0.45.
So did you get 0.348?
For So what are we looking for? Oh gosh, I am so lost. How did you guys do it by hand
So
or
what
manually?
is I took I took 320 divided by 750, which is like 43 or something like that. Subtracted 0.45 from that. And then I divided that by the square root of p, which is 0.45, times 1 minus p, which is 0.55, divided by 720.
What?
Let me write it out. 1 second.
Oh, so this is how you find this. Oh, so this is p hat minus p over. Oh, I see what you're doing. Yeah. Okay.
Oh. Did you guys get the z-score of negative 1.2848?
Yeah.
I did not, but
I just used Excel, but yeah.
What did you get?
It was. Oh, go ahead.
No, you're fine.
It was. She said that it was negative 1.284.
Oh, finally, okay. I think I got that once in my several attempts. Got a lot of weird answers.
And then do we plug that into the applet?
Yes.
yeah. Or I think you can just use the p-value that's given you right there. 0.09.
Yes. Wait, but the oh yeah.
I don't know what to go from here.
Yeah, so do we plug that negative 1.2 into the applet?
Yeah, so if you put negative 1.285 in it and then you just highlight the left, it'll get the same p-value as the Excel file.
0.994?
0.99.
Yeah,
Or,
0.99. Or 0.099?
Yeah.
0.099.
Oh, yeah, I have that. Okay. Is that what we're looking for?
Yep. We're just looking for the p-value.
So the probability is the p-value?
Yes. Well, it's that area.
Okay.
So really quick, on my probability applet, I'm getting 0.0996. So you guys said you were getting 994.
yeah, the z-score that I put in, I put negative 1.285
Okay,
instead of 284.
got it. Okay, I got the same thing. I was just concerned that it was going to change the p-value, but I got the same thing. Yeah.
Should we just put 0.099 or do we need to round that?
I think you can just put 0.9099.
Mm-hmm. All right. Are you ready for question 24?
Mm-hmm.
Okay. Suppose you're testing p equals 0.62. Again, alternative p doesn't equal 0.62. And you have calculated the test statistic to be z equals 1.334. The area to the right of z equals 1.334 under the standard normal density curve is 0.091. Which one of the following is the p-value of your hypothesis test?
So basically, we're just putting in 1.334 into the probability applet and doing everything except for the middle.
That's what I was saying. 1.334, and then what we're doing?
Selecting everything except for the middle. Something like that.
The area to the right, okay.
Oh wait.
Which of the following is the p-value of your hypothesis test? What the heck?
So I think it's just saying that you have to select both sides, like the negative side and the positive, because our hypothesis test isn't saying it's like greater than or less than, it's saying it's not equal to.
So it's 0.182?
That's what I'm getting.
Okay.
Does that make sense to you guys?
Okay.
Okay, question 25. Suppose you're a dog breeder and you want to use a confidence interval to estimate the true fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution is normal? So would it just be
But the distribution of the Cocker Spaniels is normal?
would it just be any N? Because we already know that they're normal.
That says, yeah.
I would think so, yeah.
Because I don't think this one isn't categorical, is it? This one would be quantitative.
I don't.
Well, it said that the distribution is normal, so I would think that the
Yeah,
sampling number doesn't matter.
that's what I would guess.
Yeah.
So the last one then?
Yeah. That's what I would think.
So I guess 26. A study was planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men was taken with the p-hat estimate for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform this? What are the requirements satisfied to perform this hypothesis test? Why?
So would this one be a try test? Or no, because there's only two variables. I don't know.
So I guess we're multiplying then? We're just fine. I think we're just multiplying to see if the requirements are met.
Yeah, I think so. You're right.
It's not meant for the women. If we're
So-
multiplying.
0.84 times 56 only equals 8.96, so it might be C. Or I mean D.
Yeah, that's what I was thinking.
Okay, 27.
Do you mean D? Oh, I'm sorry. I'm sorry.
Yeah. No, you're good. Yeah,
Oh.
D.
Oh, D. Okay.
6.
Sorry about that.
You're good. A study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a goal based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis?
Would it be C?
I was gonna say C, yeah.
Yeah, I agree.
C.
Mm-hmm.
It's not P1. It's not D.
P1 is for proportions, right?
I thought that was for paired samples.
No, I think whenever it's a, I thought it was whenever it was a P, it was for just for any proportions, so categorical data.
Look.
Hat ones are for the categorical. Like if you're looking at the spreadsheet.
You guys are probably right. I think it probably is.
I figured so. Then we will look for that in the text.
Yeah, I think you guys are right.
Okay.
Okay.
All right, so C.
Question 28. Weight Watchers want to predict how many weight clients would, how much weight a client will lose if they followed a prescribed exercise program in addition to their diet program. Authors were randomly divided into two groups. One group dieted but didn't exercise, and the other group dieted and followed an exercise program. For the exercise group, they used the linear regression with percent compliance with the exercise group as the explanatory variable, and the pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean?
I don't know. I don't know.
I want to say B.
I can support B.
Yeah.
That sounds good to me.
All right, I'll just go with it. Why do you think B though?
That's a good question.
I'm.
Go for it.
I was just gonna say because he was part of the exercise group,
Uh-huh.
and so I was just supporting it because if he exercised, then yeah, I probably would have lost 5.5 pounds higher. I'm not. I have no mathematical reason. I have no idea.
Well, it says right here that the residual is defined as the difference between the observed value, y, and the value that would have been predicted. So
So his observed was his actual, and his predicted. So say it
I
again.
guess that makes sense.
Okay. Because I don't think it would be C or D because I don't know, they just have added information that I don't think we needed.
Mm-hmm.
Yeah, it sounds like B matches the definition that you just read pretty well.
All right, question 29. For the study in the previous question, the B1 of the regression line was 5 pounds. Interpret this statistic.
Sure.
Wait, the B one is just the slope, right?
Yeah.
Okay. So
I don't know. My guess is C. It sounds right.
It sounds like a slope because it's like rise over run almost.
yeah. Something the same thing.
Okay.
Is that what they're comparing here? Yeah, the thing. Linear regression with percent compliance as an explanatory variable in the response. The times lost. Yeah, I would say that's probably true. That seems right. Okay. Question 30. When creating a scatter plot, a residuals plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked?
Isn't this the same one we had trouble last time?
I think so.
Isn't it like the first three you said?
Yes, but no, because there's not an actual thing, like question that we're checking. This is just in general, what do we check, right?
Aren't there 5 requirements?
There are 5 requirements.
Yes.
Linear regression,
So,
normal error.
also no normally distributed. So everything else except that, right?
Observations are independent, need to be there.
There's a linear relationship. The variance error is constant.
The x's are measured without error.
So everything but B.
I think so.
Yeah.
Okay.
Okay.
Information. Use the following information to answer the next 12 questions. Prices of supply and demand act directly on the prices of airline tickets as seats available on the flight. Fill airlines. Raise the price if the flight do not sell well and the airline may dispute the ticket. Urgent cancel the flight. Now the Heinrich or DIRs. Final student wants to predict the price of tickets. We basically read all of this already.
Oh, this is the same thing. Okay.
Compute the sample correlation coefficient of the price of tickets 14 days before compared with the price of tickets 90 days before. Give your answer accurate to 3 decimals.
So remind me what the correlation coefficient is.
Hello, puppy.
What's a ducky?
Correlation coefficient, a number that is used to measure the direction and strength of the linear association between two variables.
Okay. Okay.
It's just that R in the Excel file.
So if we just put those in with like 14 as the explanatory variable and 90 is the response, is that what it is?
I think so.
Wait, so where do we put it? I'm sorry.
So in the quantitative inference Excel sheet,
hmm
go to the linear regression tab. And then say that again, Annalisa. We're putting the 14 days first.
Explanatory table and then 90 is in response. So if you just copy and paste it, that would already be right.
If we're going to linear regression,
Mm-hmm.
the correlation coefficient is R?
So 0.780.
Yeah, that's what I got.
Wait, so hold on. I'm confused. So is R the correlation coefficient or what is it?
That's the symbol for it.
Okay, so what do I put in for explanatory variable then?
Explanatory variable is the 14 days.
14 days. And then the 90 days is the response variable.
Okay. Oh, okay. So when they talk about the correlation coefficient, that usually talks about like linear regression then?
Bivariate data. That's the lesson that it's in.
Yeah. Okay.
So question 32, create a scatter plot using these two variables. Using this scatter plot and referring to the correlation coefficient, select the answer that best describes the data illustrated in the scatter plot.
Fairly strong positive. Copyright.
That's what I would say.
I think so.
Okay.
Would it be B?
Yeah.
Okay. Okay.
All right.
Go for it.
For the next few questions, compute the y-intercept and the slope of the linear regression line used to predict the price of the tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. So what is the y-intercept?
I got negative 17.087.
I got the same.
Yes.
Do you know if you're supposed to use unstandardized or coefficient?
Wait, what?
On the Excel sheet, it has the y-intercept and the slope of both coefficients and unstandardized. So how do you know which one you're supposed to use?
Oh, that's interesting. I usually just use the B, and that usually is the right one, but that could be wrong.
I have no idea. But
Well, if it ends up being wrong, then we know it's the other answer.
Okay, question 35. Predict the price of the tickets listed 14 days before a flight based on the same flight costing $200 90 days before. Is your answer accurate to one decimal place? So our basically will just be we will just be putting it into like the slope intercept.
So you're putting it into the where the X is. You're putting that number there, and then you're going to get the prediction for the Y interval. Where is it? Costing $200.
But then which number? Oh, the predicted 177. So 177 point.
Yeah. So 177. Yeah. The predicted. So 177.3.
Yeah.
Yeah.
Okay.
For the next 3 questions, construct a 95% confidence interval for the slope of the regression line obtained when 90 days before flight ticket prices are used to predict 14 days before flight ticket prices. What is the lower bound of your confidence interval? Wait.
Do we need to switch the 90 and 30?
Is that what we have to do?
I don't know.
Which one's the 90 days?
Right now, it is the response variable, but
Of the regression obtained when 90 days before are used to predict 14 days. So are we looking at the 90 days then?
I think we do have to switch it because wouldn't the 90 days be used to predict 14? The response is 14.
I'm very confused. Oh, they're right there. Never mind.
So I put the 90 days first as the explanatory and then 14 days as the response. And then we're taking the slope of the regression line in confidence interval.
$90 days goes first.
That's what I think.
I'm so confused. What is this?
Okay, so it says that you put the value you want to predict on the y-axis. So we want to predict 14 days, so it would be the response variable.
So what should we do? What should we do? I'm really confused.
So yeah,
So the 90 days is the explanatory variable, and the 14 is the other one.
Okay.
And then it should just give you the confidence interval.
Yeah, but there are two of them. Which one do we use?
the slope one.
Why do we use the slope one?
Because it says we're looking for the slope of the regression line.
Okay, that makes sense. So 0.518.
Mm-hmm.
And 0.375 or 735.
And then margin of error.
Is just the difference between those divided by 2.
Yes.
So you subtract those two and then divide it by 2?
Yep.
Okay. I got, oh, go ahead.
I got 0.1085.
Yep.
Yeah.
So 0.9.
Mm-hmm.
Okay.
For the next 4 questions, conduct a hypothesis test to determine if the slope of a true linear regression is not equal to 0. The correct null and alternative hypothesis test for this analysis. So it would be D, is that right?
You said B, right?
You said D.
Or I mean, sorry, D.
Yeah.
D.
D as in dog.
So D?
Yeah.
Mm-hmm.
Okay.
Okay, what is the value of the test statistic?
Are we still looking at this
I don't think so.
backward?
It's in a true. Let me check 1 second. Use the following information for the next 12 questions. You're on 31. So which one are you on now?
So I'm assuming that we haven't, we keep it as it is?
Yes.
I guess so.
Okay. So which test statistic do we use? The slope?
We're just do the slope.
Yeah. So 11.510.
Yeah.
Oh. P-value is just 0.
We're just 0.000.
I guess so.
So that would be rejecting all.
There is sufficient evidence, blah, blah, blah.
Yes.
We're almost done, guys.
Oh my goodness.
Okay, question 43. In the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies born. In study, 30 mothers of all who live in poverty participate in the program, and birth weight data is recorded. Which hypothesis test would be most appropriate for the study?
paired, right?
Yeah, that's what I would think. Oh wait, paired? What are the, wouldn't it just be, because there's not two different samples, are there? Isn't it just one?
Well, because wait.
Isn't it just the birth weight weighted?
Well, I guess because not like they're gonna try it for two different babies, right?
Yeah. I would think it's just a one sample z-test because they give us the mean of the population, but I guess they don't give us the standard deviation. So
Mhm.
that would be a t-test.
So what's the difference? Tell me this. What is the difference between a z-test and a t-test?
I think a z-test, they give you the standard deviation for the population.
Okay.
For a t-test, you're using the standard deviation from your sample.
Oh gosh, how do I figure that out? Okay.
All right.
So I think this one's a t-test.
A t-test?
T-test.
Wait, you said because we don't have a standard deviation for the whole
For the
population,
population, yeah.
only the sample.
Yeah.
Where's
Okay.
the standard deviation for the sample?
Well, that's something you could solve for because you have the sample.
So it would just be one sample t-test?
I think so.
Yeah.
Because the next one gives you the standard deviation for the population.
It does?
I mean, like question 44.
It does?
Yeah, it says engineers in an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline. Always 0.03.
Oh, okay. Okay.
I would guess that's a z-test. Unless it's saying that it's just the refinery, but it sounds like that's the population they're looking at. So
So is it one sample z-test?
I think so.
Okay. The next one. An attorney wants to know whether percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate in this situation?
Would be proportions?
That's what I was thinking.
Is it a test of one proportions?
Yeah.
Alright, 46.
Okay.
Okay. Marriage counselor conducted a study of couples categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. Which type of test would be most appropriate for the study?
Two proportion.
That's what I'm thinking.
Question 47. A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between the sales and the amount of money the client is in radio advertising. Which procedure would be most appropriate for addressing this question? So, linear regression?
Yeah.
No. Okay. I will submit it. I have to go. But I'll let you know if there's anything that's wrong.
I think there's nothing wrong.
Hopefully not.
Please, please, no.
There's like 7 questions now.
Wrong? Oh my gosh. Which one?
Okay, 1 second. Question 35, 34, and 35, and 33. So I'm guessing with those ones, you probably just have to switch it from 14, switch 14 to the y-intercept instead of the x.
Wait, so which ones were they?
33 through 35. And then question 30, we got 0.4 out of 1 point. So part of that one's wrong. And then question 27. And question 18. And question 13. And then question 11, we got 0.6 out of 1, correct?
Lovely.
That's it, I think.
Which one do you want to start with?
Okay, so real quick, 27, I think that was just B. Oh, how can we do this?
I don't know if I can, if the video will keep going since I started it.
Right. Well, and then you'll have the link to it as well.
Yeah, I don't think we have to post it though today.
Oh, okay.
But I videoed it anyway, but my ride is here to go to Utah. So,
Okay.
so if you guys want to just do a hangout like off of Gmail, then you can finish up all of them.
Okay, cool. Okay, well, let's see. Just if you leave, I think it might.
Here, I'll try leaving. If it doesn't work for you guys, then you guys can set up another one.
Okay, sounds good.
Yeah, good luck.
Yeah, good luck.